In this video, we're taking a look at a medication that gives us a lot of options. And so there would be a lot of options for right answers, and you really get to pick, which is an uncomfortable thing, and yet you also have to really communicate what you've done so that I, as your instructor, know it's right, but in real life, so that someone else can check your work and know that it's right. So let's take a moment to read. We have an order for 2 million units as an IV, and we're asked how many milliliters should you administer, and we're asked to label the bottles. So we're doing a lot of work here. Let's take a look. We have this penicillin G potassium. We see that the label in the middle there tells us that it's 20 million units in the package, and it's for IV infusion only. So there's some good things, like confirmation with what we have. The first thing is that this 2 million units feels like a huge order, but when there's 20 million in the package, you're like, okay, kind of matches up. Second thing, we see our order here is as an IV, and we see that this med is for an IV. So that matches up. I realize that I can't do any math yet because this 20 million units is not a fraction. So even though it tells me there's plenty in the container, I don't know how much to withdraw. I see over here to this side that the recommended storage in dry form. And so that gives me a hint that this is going to be a med that needs reconstituted. And if I would read further, it says after reconstitution right here, the solution should be refrigerated, discard any unused solution after 7 days. So yes, needs to be reconstituted. So let me look at the rest of the fine print to see if I can figure out how it needs to be reconstituted. So on the other side, I see that this is a bulk pharmacy package, and usual dosage is anywhere from 6 to 40 million units daily by intravenous infusion only. And so I'm guessing that the 2 million units we're giving is going to be multiple times a day to get up to that minimum usual dose of 6. But again, doesn't impact my math, isn't the information I need yet. When we're doing med that needs reconstituted, the two things we need is how much liquid we're going to add to the med and how strong it is. And so I have a chart here. So this first column of my chart says the milliliters of diluent added. So that's telling me one of the things I need, how much to add. And then the second one tells me the strength, the approximate units per milliliter. So how do I pick? Well, the truth of the matter is there's not a wrong answer to pick, but you do have to pick. So for me personally, and as a good rule of thumb, you want to pick a strength that is close to your order. So my order of 2 million units, the strength that is closest to that is 1 million units right here. In our original instructions, it said that when we reconstitute a med, we need to circle the strength. So I am here circling the strength so that the next person doesn't have a choice. They see that this is what has been chosen. So that allows me to do the math. That's the piece I needed. And so in the dimensional analysis strategy, we always start with the order, 2 million. Make sure you get all those zeros in there. Use some commas to help you. 2 million units is ordered. Put it over 1. Set up my dimensional analysis with 1 million units in the denominator. And you might even be able to do the math in your head because we picked something that is close. Next to 1 milliliter, cancel, cancel, and I would give them 2 milliliters. And I would add that to their IV fluid for that to infuse. Now, we're not done because we need to label the bottle appropriately and we need to understand what's on this bottle. So this 11.5 would be the diluent that we added. So when we got the med from the pharmacy, it was in powdered form, in dry form. We would have measured out 11.5 milliliters, added it, shook it up, and then we would have had the strength of 1 million units per milliliter. Since we're only using 2 million units out of the 20, there is going to be med remaining in the container for others to use. And so we see how to store this in refrigeration, and we see that it's good for 7 days. And we had seen earlier that this usual dosage starts at 6 million units per day. So we probably need this med again, maybe even in our shift. We do need to put the time and date because it does need to be discarded after 7 days. So for me, I'm making this video on 8/22, and I cannot write sideways with this stylus, so I'm going to write across here 8/22, and you would put the year as well. And then the time for me right now is 10:41 a.m. And so I put that with the AM, or you can use the military time construct where you would just say 10:41. And then prepared by, this is where you would put your signature. And so I'm putting my initials here, and then you would put your credentials, which would hopefully be like RN. But I have a master's degree in education, so definitely not the person who should be reconstituting this, but I am the person who can teach you about it. So when we're told here, label the bottle, we had to get 3 key things there. And those 3 things are that we had to circle the strength, which we did. We had to put time and date, which we did. And we had to put our signature and our credentials, which we did. So circling back, in this problem you could pick, and we picked to use the strength of 1 million units per milliliter because it was closest to our order. If you had picked one of the different strengths, you would have gotten a different answer for the number of milliliters, and you would have still been right. So that's why it's so important that you circle the strength so that everybody knows how strong it is, and so somebody could check your work and duplicate the answer.